So we'll pick up where we left off last time with this function. In this case, we don't have to write an equation. We don't have to write an equation. We have the equation. We can just read the information off of it. But we also have the graph, so we can figure out where everything is. When we're looking at the equation, we need to figure out where the middle is, and that is going to be the constant term outside of the trig function. So the middle is the vertical shift, and it is at +1. What that means is that the y-coordinate of every point along the middle, like P and R, both have y-coordinates of +1. For the amplitude, we go for the coefficient of the trig function. So our amplitude here is 4. The amplitude is always the absolute value of the coefficient of the trig function. So even though the coefficient of sine is -4, the amplitude is a distance, and so it's always positive. So just grab +4 for the amplitude. The period is not a number that appears in our equation. We get that from the equation. We get that from the coefficient of the variable. So in this case, b is equal to 3. The period is normally 2 pi over b. But this problem is in degrees. So instead of 2 pi, we're going to use 360. The reason that we're using 360 is that the problem is written in degrees. Okay. So the period of this function is 120 degrees. B is the number that's in the equation. 2 pi divided by b, or in this case, 360 degrees divided by b is the period of the function. So if we look at this +5, this is going to tell us the horizontal shift. Not the +5. The horizontal shift is what comes after negative. So we say theta minus a -5. And then we can read the style of function as negative sine. And that would make our starting point P. Because P is at the middle and going down. Now, if we use this information to label what's going on, the coordinates at P, since that's our starting point, the x-coordinate will be the horizontal shift, and the y-coordinate will be the middle. So that point is at -5, 1. The entire period is 120 degrees. And so each of the points in the quadrant, so at Q, R, S, and then at the end, that is 1/4 of the period. So 1/4 of the period is 30 degrees. That means these points are going to be 30 degrees apart. So each of those points will be 30 degrees apart, and that's from the x. So if we start off at -5, -5 plus 30 will put us at 25. And the bottom of the graph, if the middle is at 1, the bottom is 4 lower than that. So 1 minus 4 is -3. So 25, -3 for that point at the bottom. 30 degrees later, we get to point R. So 25 plus 30, that'll put R at 55. And we're back at the middle, and the middle is at 1. Thirty degrees after that, we'll be at 85. And here we're at the top. 1 plus 4 is going to put us at the top of 5. This next point here would happen 30 degrees after the 185, or 115. And we're back at the middle with a +1. So we'll list the points down below. P is at -5, 1. Q is at 25, -3. R is at 55, 1. And S is at 85, 5. There are two problems in which we're solving an equation. Two problems in which we are solving an equation. Oh, I don't get the whole thing. Bummer. One of them says we have to solve the equation for g of theta is equal to 5. And there's only one point in this range where g of theta is equal to 5. We look for a point with a y-coordinate of 5. Well, find the theta coordinate of a point with vertical coordinate of 5. So that's point S. And so we just say theta is equal to theta is equal to 85 degrees. And for the fourth part of this question, this is the halfway point. So solve the equation g of theta is equal to 3. We want to notice that 3 is halfway between the middle and the top. The reason that I chose 3 in this problem is that 3 is halfway between the middle and the top. So we will hit the halfway points 1/3 of the way through the middle in each of the quadrants. So here's 1, and the top is at 5. Halfway through is where we are at 3. And we can see that there are 2 points where this happens. So those are the 2 solutions that we are looking for. We have to figure out where they are, and they're 1/3 of the way through the quadrant. Each quadrant is a quarter of a period. 1/3 of the quarter of the period is 10 degrees. Not past, before and after the middle. So in this problem, we hit the middle. The middle happened at 55, and 1/3 of the way through, 1/3 of the 30 degrees is 10 degrees before and after the middle. Having to scan, pan and scan. 1/3 of the 30 degrees is 10 degrees before and after the middle. So what that means is that 10 degrees after the middle and 10 degrees before the middle. So 55 plus 10 degrees will put us at 65, and 10 degrees before the 115 will put us at 105. No, that's my maximum. If the graph is passing through the middle at 55 degrees and we have a period of 120, each quadrant is 30 degrees. 1/3 of the 30 degrees is 10 degrees. 10 degrees after the 55 and 10 degrees before the 115 is when we will be passing through the halfway point. This is the fast through the middle and slow for the curves. These are the things that you'll have to do for the second graphing question. In this case, I will give you an equation and ask for the information. So in this style of problem, you have to look at the equation and read the information rather than look at the graph and read the information. Go on to the last problem. In the last problem, this is just remembering our unit circle. This is just a summary of the unit circle problem. So I have a bunch of angles in degrees up top, and I'm looking for the radians, the radian equivalent, and then I'm looking for the sine, cosine, and tangent of all these values. And I've just kind of erased one and replaced it. So, for example, this pi over 4, we know that pi over 4 is 45 degrees. We can identify 30 degrees as pi over 6 radians. 60 degrees is pi over 3 radians. 90 degrees is pi over 2 radians. These are the easiest ones to identify. 180 degrees is pi radians. 150 has a 30-degree reference angle in the second quadrant, and that happens at 5 pi over 6. There are some missing values here, but I put them all in order. Down here, I've said that I want to know this. If I need to know about this column, all we know is that cosine of theta is equal to 1. So this must be happening at 0 degrees, which is also 0 radians. So if we imagine that point on the unit circle, the sine is 0. Tangent is sine divided by cosine, so tangent is also 0. In this root 3 over 2, we have the sine of square root of 3 over 2. Sine of square root of 3 over 2 means we have a 60 degree reference angle. And so that means this must be the 120, because I've already got the 60 covered over here. So sine of 120 is root 3 over 2. That 120-degree angle is going to be 2 pi over 3 radians. If sine is root 3 over 2, then cosine is a half. Since we are in the second quadrant, cosine is negative. Tangent is sine divided by cosine, so root 3 over 2 divided by negative 1 over 2, negative square root of 3. And so this is how we're going to play this game. The one that's a little bit sneaky is at 90 degrees. At 90 degrees, sine of 90 is 1, cosine of 90 is 0, and 1 divided by 0 is undefined. So we can just write undefined, or abrev undefined. So we just need to complete the table of values for for problem 5. This is our units, the first part of the unit circle. For problem 6, this one is a little bit different than what we've done before. We're given that sine of theta is x over 3. So the game that we want to play here is that if I draw a right triangle, keep myself a right triangle. If I think about a right triangle, if sine of theta is x over 3, if sine of theta is x over 3, we're getting the opposites and the hypotenuse. Sine is opposite over hypotenuse. So opposite the theta, I will just write x. And for a hypotenuse, I will use 3. From here, we can figure out the adjacent. And then cosine of theta will be adjacent over hypotenuse. That's the strategy that we want to use in problem 6. When I say sine of theta is x over 3, I'm saying x is opposite and 3 is hypotenuse. We can use 2 of those to find the third part. And then just put that back together, put those 2 parts together to get cosine. Find the adjacent, and then put the adjacent and the hypotenuse together to get the cosine. Okay. I do have a supplemental practice final exam that I'm going to post to go over next week. So this will be additional. So there'll be an additional announcement with the final exam practice part 2. This will be some more unit question problems. Unit circle questions. As well as some solving equations problems. Solving equations problems are just variations of the unit circle problem. The solving equations problems will be the reference angle and quadrant style. So we'll publish part 2 of the final exam for final exam practice. And we will use that we'll go over those problems next week on Tuesday and Thursday. That'll be Tuesday. Let's see. Tuesday the 13th and Thursday the 15th. There is no class on Tuesday the 20th, the final exam. And the final exam will be on Thursday the 22nd. Any questions? That's going to be it for today. I will post these solutions on the Canvas for you to practice. That's it for today. I will see you all on Tuesday. Everybody have a good weekend and thanks for playing.